Welcome to another video on vcloudlabs. Today, we're going to talk about a really powerful feature in Kubernetes, Pod Priority and Preemption. When you use this thing correctly, it can seriously be the difference between a minor hiccup and a full-blown outage. So let's dive right in. Okay, so imagine this scene. Your cluster is humming along, everything's great. But then maybe traffic spikes, a big job kicks off, and boom, it's full. There's literally no more room. And it's at that exact moment that your most critical API server needs to scale up. So what happens? Does it just get stuck waiting in line? This is the core problem we're going to solve today. All right, here's how we're going to tackle this. First, we'll look at the full cluster problem itself. Then we'll get into what pod priority is and see how its muscle, preemption, actually works. After that, we'll cover some advanced rules you absolutely need to know. And we'll wrap up with exactly when you should, and maybe more importantly, when you shouldn't use this feature. First up, let's really get our heads around the default dilemma, because without any special setup, the way Kubernetes handles a full cluster, well, it can be a real problem. See, by default, Kubernetes is totally fair. It treats every single pod the same. Your mission critical API gateway, it's just as important as some background analytics job. So when that cluster fills up, your critical new pod just sits in a queue, stuck in pending, waiting for space to magically appear. And in a production system, that's not going to work. So how do we fix this? Well, we have to teach Kubernetes what actually matters to our application. And we do that by defining pod priority, which lets us build a clear hierarchy of what's important. At its core, pod priority is actually super simple. It's just a number. You attach this number to your pod, and it basically tells the scheduler, hey, pay attention to me. The higher the number, the more important the pod. It's a direct signal of who gets to go first. Now, here's the thing. In practice, you don't just sprinkle numbers directly in your pod YAML. Instead, you create this cluster-wide object called a priority class. Think of it like a reusable template. It maps a friendly name, something like high priority, to that specific integer value. And here's what one looks like. It's pretty straightforward. You've got the name, which is how you'll refer to it. You've got the value, that's the actual priority number, in this case, a nice big 1 million. And notice that global default is set to false. This is a really good idea because it means pods only get this high priority if they explicitly ask for it. So how does a pod ask for it? Just like this, it's one line. Inside your pod spec, you just add priority class name and give it the name of the class we just made, high priority. And that's it. The Kubernetes scheduler now knows this pod is a VIP. Okay, so our pod is a VIP. That's great. But the cluster is still full, right? Having a high priority doesn't magically create new servers. This is where the real action happens. Let's look at how preemption actually makes room for these critical pods. The scheduler follows this really logical, almost ruthless process. First, our high priority pod shows up that can't find a home. The scheduler doesn't just give up. It starts scanning for a node where it can evict or kick out less important pods. Once it identifies these victims, it sends them a termination signal, waits for them to shut down, and then boom, our high priority pod gets scheduled in the space that was just cleared. Now, you might be wondering about those poor evicted pods. Does this mean instant death? Well, no. Kubernetes is polite about it at first. It sends the victim pod a SIG term signal and gives it a graceful termination period to finish up its work and shut down cleanly. This is why having well-behaved apps that can handle shutdown signals is so important, especially for your lower priority stuff. If they don't cooperate, though, then they'll be forcefully terminated. So this is a seriously powerful tool. But you know what they say, with great power comes the need to really understand the details. Let's explore some of the advanced rules and nuances you absolutely need to know before using this in production. So what if you have a pod that's important, but maybe not kick other pods out important? Think of a long-running data science job. You want it scheduled as soon as possible, but you don't want it to disrupt your live web servers. For this, you can create what I like to call important but polite pods. And you do this with a single setting in your priority class. Preemption policy, never. A pod using this class will still jump to the front of the scheduling line because of its high value, but it will wait patiently for resources to free up on their own, instead of evicting anything. It gets priority in the queue, but it won't kick anyone out of their seat. Okay, this next point is a super common point of confusion, so it's not. Pod priority is not the same thing as quality of service, or QoS. Priority is all about the scheduler deciding which pod gets a spot first when there's a traffic jam. QoS, on the other hand, is about the kubelet on a specific node deciding which pod to kill when that node itself is running out of memory or CPU. They're related for sure, but they solve different problems. And before you go all in with this, you have to be aware of these critical limitations. First, pod disruption budgets, they're best effort, not a guarantee. If the scheduler has no other choice, it will violate a PDB to place a critical pod. Second, preemption is a single node deal. It's not going to evict a pod on node B to satisfy some anti-affinity rule for a pod on node A. And finally, and this is a big one, if everyone has high priority, no one does. You have to control who can use it, maybe with something like resource quotas. So all of this brings us to the final and maybe the most important section. Where should you actually apply this stuff? Using priorities strategically is absolutely key to a stable cluster. The best use cases are for the absolute pillars of your infrastructure. We're talking about your API gateways, your core backend microservices, essential add-ons like monitoring or logging agents, and anything that is directly customer facing. These are the workloads that, if they can't run, cause an immediate and very visible problem. And on the flip side, you want to avoid using high priority for anything non-essential. Development and test pods should never be able to preempt production workloads. Large, disruptive batch jobs are also pretty bad candidates, unless, of course, you're using that polite, non-preempting policy we talked about. Basically, if a task can fail and just be retried later without a big deal, it does not need high priority. And that really is the bottom line. When your cluster is under pressure, having your priorities straight means your system can degrade gracefully by sacrificing the less important work instead of just collapsing into a full-scale outage. It's an incredibly powerful way to build resilience. So the question to ask yourself is, which of your workloads are truly non-negotiable? I really hope this gives you a solid handle on pod priority and preemption so you can use it in your own clusters. It's a feature that really demands careful thought, but it pays off big time in stability. And in the end, thanks for watching the video, and do follow, like, subscribe vCloudlabs channel.